Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sheraz, and in today's lecture we are going to discuss about the fundamental particles. But before going into the discussion and the details of the fundamental particles, we are going to discuss about the subatomic particles. The word indicates these are the particles that are smaller than atoms and found within atoms. There are two types of the subatomic particles. One is the composite and the other one is the fundamental or elementary particles. There is a lot of confusion about the fundamental particles or the elementary particles, and most of the people do not know that what are the fundamental particles. They include all types of the subatomic particles within the category of the fundamental particles, but this is wrong. So you must understand here what is the difference between the fundamental particle and the composite particle. If we talk about the composite particle, as the word indicates, these are the particles that are having some internal structure and they are further made up of some smaller types of the particles. And among the category of the composite particles, protons and neutrons are the most important composite particles, and these are further made up of some smaller particles. And if we talk about the fundamental particles or the elementary particles, so these are the particles that do not have their internal structure and they are not further composed of any smaller particles. So among the category of the fundamental particles, electrons are the most important elementary or fundamental particles. Apart from them, quarks are also included in the fundamental particles, and basically protons and neutrons are made up of the quarks. So protons, neutrons are composite because they are made up of the quarks or number of quarks. Basically the topic is subatomic particle. So among the category of subatomic particle, we would discuss the composite particle as well as we discussed about the elementary particles. So first subatomic particle is the electron. So first recognized negatively charged particle that was suggested by the J parent. So electrons were the first type of subatomic particles that were recognized, and a person named J parent suggested that the electrons are negatively charged. They carried out number of experiments in which they proved that the electrons are negatively charged particles because in the presence of electric field they were deflected toward the positive plate. The next person, J.J. Thomson, proved it to be fundamental particle. J.J. Thomson was the person who proved that the electrons are fundamental particles and these are found in each and every type of the atom. If we talk about the charge of the electrons, so charge is 1.6 into 10 to the power minus 19 coulomb or 4.8 into 10 to the power minus 10 ESU. Basically there are two units of the charge. The one is coulomb, that is the SI unit, and the other is the ESU, electrostatic unit, that is basically the serious unit of the charge. If we talk about the mass, the electrons are having very small or minute mass, and its mass is equal to 9.11 into 10 to the power minus 31 kilogram. That is very small mass. Electrons are the stable particles outside the nucleus, so they can exist outside the nucleus and they are stable. If we talk about the spin may be plus 1 by 2, minus 1 by 2. Basically electrons are continuously spinning about their axis and their spin may be plus 1 by 2, minus 1 by 2. Plus 1 by 2 shows that the spin may be clockwise and the minus 1 by 2 shows that the spin may be anti-clockwise. The next important subatomic particle is proton. These are present in all atoms. Positively charged particles, charge equal to electron. If we talk about the protons, they are extensively found. They are found in every atom. Their charge is equal to the electron but with an opposite sign. Electrons are negatively charged but the protons are positively charged. If we talk about the spin of proton is also plus 1 by 2, minus 1 by 2, same as the electron. They are stable particles and first produced by Rutherford. Basically Rutherford was the first person who produced the protons artificially, and this section is showing the production of protons by Rutherford. He bombarded the nitrogen 714 isotope with helium are the alpha particles, and he produced oxygen 817 isotope along with the proton. So protons were first produced by artificial radioactivity by the Rutherford. Next is the neutrons. If we talk about the neutrons, they were discovered by the James Chadwick in 1932, and this was the experiment through which James Chadwick discovered the neutrons. He bombarded the beryllium target with the alpha particles from polonium source, and as a result carbon 612 isotope was produced along with the production of some highly penetrating particles. And as these particles were shown neutral by the charge detector, so James Chadwick named them as the neutron. These are present in all atoms except the protium. Basically, neutrons are found in each and every type of the atom except the protium isotope of the hydrogen. You people know that hydrogen is having three isotopes: protium, deuterium and tritium. And protium is an isotope which is having no neutrons. These are unstable particles outside the nucleus, and they decay when they are isolated and outside the nucleus. So this is the reaction that is basically showing the decay of the neutrons. That is, neutron decays into a proton, into an electron, and this is a small particle, that is nu minus, that is called the anti-neutrino. In the next portion, we are going to discuss about the neutrino and anti-neutrino. Neutrons are having no charge, as I mentioned earlier, but their mass is equal to the mass of protons. If we talk about the spin of neutrons can be clockwise, it can be anti-clockwise. Next is the positron. These are the antiparticles of the electron. Basically, antiparticles are those that are having same mass but opposite charge. So positrons are antiparticles of electron, which means that their mass is equal to the electron, but their charge is same but opposite to that of the electron. C.D. Anderson discovered in cosmic rays. Basically, cosmic rays are high energy radiations that are bombarded by sun towards the earth. So they were discovered in the cosmic rays. Mass same as that of electron but opposite charge. As I mentioned earlier, the positron is having same mass that of electron. Charge is also same but with an opposite sign. The stable particle, but upon interaction with electron, it annihilates. So positrons are also stable particles, but when they interact, when they collide with the electron, they annihilate. What does annihilation mean? It is the complete destruction of a particle into energy. When electron and positron meet, they strike with each other. They are having same mass, opposite charge, so they strongly attract each other, and upon their collision, both particles are converted into the energy and they release radiations, and both the particles are annihilated. You people have studied the annihilation of matter, so this is basically the annihilation of matter. That is the complete destruction of the matter into energy. So beta plus means positron, beta minus mean electron, and when they meet each other, they collide each other. So the result is 2H nu, stands for the radiation. The next subatomic particle is the neutrino and anti-neutrino. These are negligibly small particles. Neutrino emission was first observed by the Pauli. During the decay of proton, neutrinos were first observed to be produced. The proton is decayed into an electron, a neutron, and the nu. Nu is basically a small particle that are known as the neutrino. Negligibly small mass and no charge, so they are neutral. And if you talk about the antineutrino, these are the antiparticles of the neutrino. So antineutrino emitted during neutron decay. So this is the equation that is basically showing the decay of a free neutron, as it is mentioned earlier. So a neutron decays into a proton, electron, and nu minus. So this is nu plus, so this is nu minus. So both these are the antiparticles of each other. Their mass is same, but what is the difference between them? Basically the difference is of the spin. One spins clockwise and the other spins anti-clockwise. It's also having the negligible mass, and their emission is necessary to conserve the momentum and the energy of the system. The last subatomic particle is the meson. Yukawa proposed the presence of meson. Basically, Yukawa was a nuclear scientist, and during his research, he proposed the presence of mesons. And the C.D. Anderson was the person who proved the presence of mesons in the cosmic rays. Mesons are the particles that are having mass intermediate to that of the proton and the electron. And the mass of mesons is 207 times that of an electron. So they are massive than electron, but they are lighter than that of the protons. And they are represented by the mu. So they are also called the muons. Mesons or muons are the two terms that are used for the same particles. So they can be plus mesons, they can be minus meson. So this was all about the subatomic particles. If you have any question related to this video, you can post your question in the comment section. Allah Hafiz.